So basically we are studying resolution and magnification today, and we are relating it to the electromagnetic spectrum. You need to learn the definition of resolution and magnification as mentioned on this text box. What's resolution? It is the ability to distinguish between two objects which are very close together. The higher the resolution of an image, the greater the detail that can be seen, which means clarity of the image. As I mentioned earlier, magnification is the number of times greater that an image is than the actual object. And magnification, we have already discussed in your O level that its formula is image size divided by actual or real size of the object. To understand the concept of resolution, we go to the details of how wavelengths interfere with this resolution and clarity of the image. At least half of the wavelength must pass through the object for it to appear clearly. In figure 1.1, you can see the electromagnetic spectrum. You can see the visible light is having the range from 400 nanometer to 700 nanometer. All these are bundled together in white beam. So the white light that we use in the light microscope, it is having the shortest wavelength 400 nanometer as well as the longest wavelength 700 nanometer, and all the wavelengths from 400 to 700 are there in the white beam. So how is this related to resolution, or how do we perceive what we see? Figure 1.12 shows you the wavelength of 400 meter passing through different size objects, and you can see there's an object of 1000 nanometer diameter, which is mitochondrion here. You can see that it is interfering with the wavelength, and it will be visible to you because it has interfered with the wavelength. But the structures which are very small, for example, ribosomes, which are having diameter of only 25 nanometer, they will not interfere with the wavelengths much, so they will not be visible to you. How much wavelength must get interfered? At least half of the wavelength must pass through the object. What is the shortest wavelength visible to you? 400 nanometer is the shortest wavelength visible to you. So any structure which is smaller than 200 nanometer will not be visible to you. Any object greater than 200 nanometer will be visible to you, because the limit of resolution is half of wavelength used as a source of illumination, and the shortest wavelength which we are seeing with our eye for the visible range is 400 nanometer. Half of that is 200 nanometer, and this brings us to the conclusion that objects smaller than 200 nanometer are not visible in the light microscope. Objects which are larger than 200 nanometer, for example, the mitochondria, the nucleus, the cell itself, they are all very well visible because they are larger than 200 nanometer. They allow more than half of wavelength of light to cross. The magnification and resolution still of light microscopy is low. So this caused the scientists to come up with an electron microscope and other technique from which we can view objects which are even smaller than the typical resolution of light microscope, and that was the technique of electron microscopy. Then what's an electron microscope? Electron microscope is a bit similar to what you have studied in your O levels as cathode ray oscilloscope. You can recall that and related with what we are discussing electron microscope, there is an electron gun here, which is the anode. It produces an electron beam in vacuum. The entire tunnel is in vacuum. There are different lenses placed all along the path of this electron beam, and these lenses are all electromagnetic in nature. You apply potential difference on these electromagnetic lenses so that the path of the electron beam can be focused onto the specimen, and the image can be projected onto a photographic plate. The photographic plate is the one where the image will be displayed. Since it is an X-ray, or it is the image will be similar to X-rays, because X-rays are also electron beams only. So the image produced here will be a grayscale image. This image will be grayscale because the specimen that you place in the center is not having any aqueous dye, and it is not having any aqueous stain. How do you stain the specimen? The specimen is stained using heavy metals, for example, cadmium, and these heavy metal added to the specimen adds contrast to the image. The image projected onto the screen will be in the shades of blacks and whites and grays. They will be dark gray, light gray, black and white structures, which will be visible to you depending on how much heavy metal they have all taken up. But the image will be highly resolved and it will be highly magnified. The magnification will be up to 100,000 to 250,000 achievable, and resolution that we can expect is 0.05 nanometer, considering that the electron beam that we are using is having the wavelength of 0.1 nanometer only. It's a very small wavelength. The shortest wavelength here is 0.1 nanometer compared to a light microscope which used the wavelength of 400 nanometer. That was the shortest wavelength. Another important aspect of this particular electron microscope is that the entire tunnel of electron microscope must be in vacuum. Why it needs to be in vacuum? because the path of electrons may get deflected if it's not left in vacuum. Now this brings us to a problem that living cells cannot be placed as a specimen here because living cells have water and water evaporates at room temperature in vacuum. To make sure this, we dehydrate the sample, we wash it off in alcohol several times so that water is driven away from the specimen, and then we place it. So the specimen is dead. So the limitations of electron microscope is, number one, the image is not colored. Number two, it cannot view any living specimen. For example, if you want to continue and view the stages of cell division occurring right in front of your eye, if you want to view any dynamic process occurring in a living cell, this cannot be viewed in the electron microscope. But yes, the resolution and magnification will be very high. It needs extreme expertise. It doesn't come up with simple practice. So electron microscopy needs a lot more extensive practice than a typical light microscope. But yes, magnification resolution are very high for this. This is why electron microscope is used to study the details of the structure, but but still the light microscope is not obsolete. Still, everywhere wherever you go, you will see light microscope being used commonly. The image which is projected on the screen will be a grayscale image. As I told you, you can transfer the image to a computer screen, and there will be a software in the computer that can add false colors to the electron microscopy image, because otherwise the image was grayscale, so the colors can be added accordingly, and this is how the details of the image can be seen.